So we'll start the class now. So far in AC circuits, we have discussed uh, about sinusoids and phasors.
Sir, have you checked question paper?
Not yet. So today we'll be actually looking into various simple. We'll take up simple circuits first. Simple resistive circuit, simple inductive circuit, and a simple capacitive circuit, and see derive the phasor relationship between voltage and current, as well as the phasor diagrams. We'll be plotting the phasor diagrams. Uh, let's start with a simple resistive circuit. So when we show a voltage source in AC, the symbol is something like this. This means actually an AC voltage, and since it's a function of time now, both voltage as well as current will be a function of time. Now we know from Ohm's law that Vt is simply equal to It into R. Fine. This It we can write as Im cos of omega t plus phi. This is the sinusoidal form of this AC current that is flowing in the circuit. Therefore, Vt will be equal to Im R cos of omega t plus phi. Fine. So this is the sinusoidal form of voltage, uh, and this is the sinusoidal form of current. This is the sinusoidal form of voltage in for a simple resistive circuit supplied by an AC voltage source. Uh, just to recall, phi is the phase, omega is the angular frequency of the system, Im is the peak voltage of current of AC current. Therefore, Im into R will be nothing but, you can also write it as Vm cos of omega t plus phi. So you can say the peak value of voltage will be simply equal to peak value of current into resistance R. So this is the relationship between peak value of voltage and peak value of current for an AC circuit. Now let's also find out the phasor form of this voltage and current. It is equal to Im cos of omega t plus phi. We know that in phasor form it is written as I equal to Im angle phi. Fine. This is the phasor form of this current. Therefore, what will be the phasor form of voltage? Vt is Im R cos of omega t plus phi. Therefore, phasor form will be Im R angle phi, where Im R is the magnitude. It can also be replaced by simply Vm angle phi. So this is the phasor form of voltage. So we have the sinusoidal form of voltage and current for a resistive circuit. We have the phasor form of voltage and current uh, for an uh, we have also the phasor form of voltage and current for the same resistive circuit. V is equal to Im R angle phi. Since I is equal to Im angle phi, we can replace it here and we can show therefore V is equal to simply capital I into R. तो यहाँ पे notations याद रख लो. We are writing small it, small vt to denote the sinusoidal form. To denote the phasor form, we'll be writing capital V and capital I. So wherever you see now capital notations of V and I, it will be reflecting the phasor form, while as the sinusoidal form will be actually written as a function of time t, it and vt. So V is equal to IR is the phasor relationship between voltage and current. So actually Ohm's law is still valid in case of AC circuits, and for a simple AC circuit, if you want to find out voltage or you want to find out current, if you want to find out the magnitude of that, the relationship is Vm is equal to Im into R, and the same relationship is also valid for a phasor form where V will be equal to capital V is equal to capital I into R, where R is denotes the resistance. So this is a simpler circuit, a resistive circuit. Let's look into an inductive circuit. Before we do that, let's plot the phasor diagram of resistive circuit. So by phasor diagram, what we mean is we want to plot uh, V versus I plot. We want to plot not V versus I, we want to plot a vector v and vector I. We want to actually draw them using some reference, right? So what we can do is we can start by taking the voltage as a reference. We can even take current as a reference, but let us take, for example, voltage as the reference. We know that V is equal to Vm angle phi, fine, or you can say Im into R angle phi. So what is the magnitude of V? It is Im into R, and it has a phase of phi. So it is located anywhere in this direction. One minute. Hello? ऐसे भेजना. हाँ, 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 हाँ. Okay, so we are plotting the phasor diagram between V and I, capital V and capital I. V is equal to Vm angle phi. That means magnitude of V is actually Vm. So we have to actually draw a line of having a magnitude of Vm, fine, located at an angle of 5 degrees with respect to the x-axis. And as far as I is concerned in this case, what is I? I is Im into angle phi. So I is also a vector that is located in the same direction since phase is same. So I is also located in the same direction. I is also located in the same direction at an angle of phi. Only thing is its magnitude is Im, and most likely Vm is always going to be greater than Im, right? So it will be for Vm to be actually less than Im, resistance has to be less than 1, which will not normally not be the case, resistance being 1 ohms, less than 1 ohms. Most of the cases you will see resistance having a value greater than 1, so Vm will be um, normally greater than 1. There are cases where resistance value will be less than 1, and for that for those cases Im will be less than Vm. So this is the phasor diagram that you can be plotting for a simple resistive circuit. The thing here is that the direction of V Vm and Im, it is the magnitude of V and I respectively. This is your V, and this red line is your vector I. Right? So you have to actually plot the vectors V and I on this actually your complex plane. The on the x-axis is representing your real axis, and y-axis here is representing your imaginary axis. So this is your real axis, this is your imaginary axis. So if phi were to be 0, if phi were 0 degrees, in that case you could have simply plotted Vm would be in this direction along 0, and Im would also be along, V would be along 0, and I would also be along 0. So this is your phasor diagram for a simple resistive circuit. They can be at any angle phi, but the thing is जिस डायरेक्शन में V होगा उसी डायरेक्शन में I होगा resistive circuit के लिए. So between V and I the angle is 0. So for a resistive circuit, angle, or you can say phase difference between V and I is 0 degrees. Fine. So this is an important concept for a resistive circuit. The angle, the phase difference between V and I for a resistive circuit is 0 degrees. Moving on to an inductive circuit. So now you have an AC voltage and it's supplying an inductive element L. So fine. So there is a current IT that is actually flowing through this circuit. Now we know for an inductive circuit, the relationship is Vt is equal to L di by dt. Fine. So it's actually the differentiation of this current into L, that is your value of voltage across the inductive element. Now if I is equal to Im cos of omega t plus phi, that means Vt is equal to L into differentiation of Im cos of omega t plus phi, which implies L into Im being a constant. We can take it out. Differentiation of cos of omega t plus phi, that is minus sine of omega t plus phi into internal differentiation, that is omega in this case. So Vt is this minus sign, we will absorb this inside the sign, therefore it will be equal to omega L Im cos of omega t plus phi plus 90 degrees. So actually we derived this last time also, the for a differential term what will be the phasor relationship. At that time we actually saw this thing. So now what is the voltage across an inductive element? It is omega L Im cos of omega t plus phi plus 90 degrees if current through the inductive element is Im cos of omega t plus phi. So that means uh, the phasor relationship will be I is equal to Im angle phi, and the phasor relationship for voltage will be omega L Im angle phi plus 90 degrees. So this is the case here. The if the phasor voltage, if the phasor current is I equal to Im angle phi, the phasor value of voltage for an inductive circuit will be omega L Im angle phi plus 90 degrees. Omega L Im is simply the magnitude of this phasor quantity, and phi plus 90 will represent the phase for this uh, phasor voltage. So now if we were to uh, plot the phasor diagram for V and I in this particular case, this is our XY plane, real the complex plane. Again, taking voltage as the reference. So voltage is let voltage be in this direction. Fine. This is voltage V. The magnitude of this voltage is omega L I m, and the angle of this is phi plus 90 degrees. If voltage is in this direction, current will be in this direction. This will be I. The magnitude of I is simply Im, and the phase of this uh, vector I is phi. Fine. So that means this is actually this is located at a right angle, representing 90 degrees between voltage and current. So phi could have been anything. What I'm actually drawing here is, say for example, phi is equal to minus 30 degrees. So if phi is equal to minus 30 degrees, this is just an assumption. Say phi is equal to minus 30 degrees. So if phi is equal to minus 30 degrees, the plot of I will be in the fourth quadrant. You have to draw it at minus 30 degrees to the x-axis, and V will be minus 30 plus 90. That means at 60 degrees to the real axis. That will be in the first quadrant. The magnitude of phasor I is simply Im, whereas the magnitude of voltage V is omega into L into Im. So what you can see is the difference between V and I is 90 degrees in this case. So phase difference between voltage and current is 90 degrees in an inductive circuit, but you have to be more specific here. By being specific, I mean which one is actually leading, which one is lagging. So phase difference between voltage and current is 90 degrees for an inductive circuit with current lagging voltage by 90 degrees. Fine. So you can actually write with voltage leading current by 90 degrees, or you can say with current lagging voltage by 90 degrees. So for an inductive circuit, the current always lags the voltage. For a purely inductive circuit, the current always lags the voltage by 90 degrees. That means if we were to plot the sinusoidal waveform of this, if this is our voltage profile, uh, if this is our voltage V, then our current will start 90 degrees after this. So this is our current. Fine. So magnitude of current will be less, and it will be normally it will be less than voltage, and also it is actually lagging the voltage by 90 degrees. That means it will actually start after 90 degrees. Uh, so voltage and current in this case, they are out of phase. For a resistive circuit, if this is our voltage profile, this will be our current profile. This is our voltage V, this is our current I. There is a phase difference of 0 between voltage and current in case of a resistive circuit. We are talking about purely resistive circuit. Phase difference is zero. That means voltage and current, they are in phase. While as for an inductive circuit, the voltage and current, they are out of phase, and exactly they are 90 degrees out of phase, where current I is actually lagging the voltage by 90 degrees. Now taking the third case of a capacitive circuit, these are purely resistive, purely inductive, and purely capacitive circuits. This is voltage Vt being applied to a capacitor of value C. A current It is flowing through this capacitor. Let It be equal to Im cos of omega t plus phi. Fine. This is just an assumption here. This was our phase diagram for an inductive circuit. Mute your microphone. We can also draw the phasor diagram of inductive circuit for phi equal to 0. For phi equal to 0 degrees, this is our voltage that will be located not 0 degrees. This is for phi equal to if this is phi, for this particular case where phi is actually representing the angle of current, for this case if phi is equal to minus 90 degrees, voltage will be, or let us say 0 degrees. If phi is equal to 0 degrees, phi is equal to 0 degrees, that means current, the voltage will be in this direction 90 degrees, and current will be in this direction along the x-axis. This is value of current. The voltage will be 90 degrees to current. Coming back to the capacitive circuit, we have assumed that It is equal to Im cos of omega t plus phi. Now for an in capacitive circuit, we know that voltage across the capacitor is 1 by C integral of I dt. This is Vt. So Vt is equal to 1 by C integral of Im cos of omega t plus phi dt, which implies Im by C integration sine of omega t plus phi, and internal differentiation, we have to divide that. Omega will go, omega is in the denominator. Converting this sine into cos term, Im is called Im by omega c cos of omega t plus phi minus 90 degrees. So this is our voltage, the value of voltage for a capacitive circuit. And if It is equal to Im cos of omega t plus phi, the phasor form of this can be written as I equal to Im angle phi, and the phasor form of voltage can be written as Im by omega c angle phi minus 90 degrees. So what does this say us? What does this mean now? From a phasor diagram, if this is our complex plane, if this is our voltage, fine, this is our voltage V located at an angle of phi minus 90 degrees. That means our current I will be somewhere in this direction, located at an angle of phi, where V and I is actually forming an angle of 90 degrees with respect to each other. Fine. So this is, say, for example, say phi is equal to 120 degrees. Phi is equal to 120 degrees. So I will be in the third quadrant. It is at 120 degrees. It's making an angle of 120 degrees with respect to the x-axis. Therefore, voltage will be making an angle of 120 minus 90, that is 30 degrees with respect to the x-axis. This is for phi equal to 120 degrees. You can also draw this for, say, phi equal to 0 degrees.
Excuse me, sir.
Yes, current I is in this direction.
The magnitude of V will be less than I, no? In this one.
Magnitude of V is most likely always greater than current in most of the cases. V is equal to,
In this one, I divided by VC
इसका
into C,
इसका जो
so it must
इसका जो मैग्नीट्यूड है Vm is equal to Vm is equal to Im by omega C. इसका जो मैग्नीट्यूड है that is simply Im. Now why this will be still less? Because C के जो practical values है, C के values होते हैं microfarads में, ठीक है? The highest capacitance that we actually know is 1 farad, between that is जो अर्थ का हम बोलते हैं, ठीक है? कैपेसिटेंस के वैल्यूज माइक्रोफेरेड्स में होते हैं, so it will be of the order of 10 raised to -6. तो जब वो न्यूमरेटर में जाएगा, again magnitude of will be much larger as compared to Im.
तो सर इंडक्टर में छोटी हो जाएगी W V की वैल्यू, क्योंकि अगर सेम कॉन्सेप्ट अगर मान लगाएंगे
नहीं, वहाँ
C की
इंडक्टर
वैल्यू
का
काफी
वैल्यू
छोटी
इंडक्टर का वैल्यू माइक्रो हेनरीज में थोड़ी होता है, इंडक्टर का वैल्यू बहुत ज़्यादा होता है.
नहीं, सॉरी हाँ, ओके सर, ओके.
यहाँ पे इंडक्टर का वैल्यू मल्टीप्लाई हो रहा है. Also you have to know that omega is getting multiplied here. Omega का typical value, as you know, it is 2 pi into 50. That means 314 into L का जो भी वैल्यू होगा, 1 मिली हेनरी होगा या 10 मिली हेनरीज या 100 मिली हेनरीज, तो ये स्टिल Im से ज़्यादा ही होगा. ठीक है. नॉर्मली हम जब दिखाते हैं, we mostly show that V is greater than I, although V can be less than I, there is no doubt in that case. But whenever you'll be drawing a phasor diagram, you should be showing a larger length for vector V as compared to vector I. So vector V in this case, again the phase difference between voltage and current is 90 degrees, with current actually leading voltage by 90 degrees for this particular case. So actually seen three different cases. You have seen a purely resistive circuit, you have seen a purely inductive circuit, and you have seen a purely capacitive circuit. For all these three cases, what we have taken is, we have taken IT equal to Im cos of omega t plus phi. We could have even started with the voltage. We could have taken Vt as the reference there. We could have started with Vt equal to Vm cos of omega t plus phi, and current को हम derive कर सकते थे, but हमने current को ले लिया और voltage को derive किया. It's one and the same thing. For all these three cases, what we have done is we have taken IT as the reference to find out voltage, and what we have seen is voltage, uh, the sinusoidal form of voltage will be Vt simply Im into R cos of omega t plus phi ऐसे ही. ठीक है, this is point number 1. This is point number 1. IT is this. If IT is this, then we have seen that voltage is Im into R cos omega t plus phi. Voltage is omega L Im into cos of omega t plus phi plus 90 degrees. For a capacitive circuit, we have seen Vt is equal to Im by omega c cos of omega t plus phi minus 90 degrees. Fine. So this is the value of voltage we have found in for in the sinusoidal form. In the phasor form, we have seen that V is equal to simply I into R. V is equal to I into j omega L, and for this case V will be equal to I divided by j omega C. ठीक है? So what we have seen here is V and I are in phase. In this case, we have seen I is lagging V by 90 degrees. In this case, we have seen that I is leading V by 90 degrees. ठीक है, तो ये आपको purely resistive circuit, for a purely capacitive circuit, and for a purely inductive circuit. You have to remember these points. What is the voltage current relationship? What is the phasor diagram between voltage and current? And for an inductive circuit, what is the phase difference? What is the phase difference for a capacitive circuit? And also you have to remember which quantity is actually lagging in an inductive circuit, which one is leading, and similarly for a capacitive circuit, which one is lagging and which one is leading. This is important. So I'll stop here today. Any questions regarding